Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to continue with a series of quiz lectures, and today is a new quiz, new questions from MET, REGS, NAV and Tech. So let's start with question number 1 for today. What is the SI unit that results from multiplying kilogram and meter per second square? So kilogram into meter per second square. So kilogram is the SI unit of mass. When you multiply mass by meter per second square, which is the SI unit of acceleration, you get mass into acceleration equals to force. And the SI unit of force is newtons. SI unit of force is Newton. So the correct option here is option number Bravo, Newton. Let's go to question number 2. So quick recap, kilogram into meter per second square. So corresponding term associated with them is mass into acceleration, which is force. The SI unit of force is Newton. So option number Bravo will be the correct option. The mean chord is equal to what? So the formula for mean chord is wing area divided by wingspan. Mean chord equals to wing area divided by wingspan. Now let's look at the numerical. Wing area is 200 feet per square. Wing area divided by wingspan is your chord. Mean chord. Okay. So wing area is 200. Wingspan is 50. So your mean chord will be equal to 4 feet. 20 divided by 50 is 4 feet. Okay. So correct option will be option number Charlie. Question number 4. The part of an aerodrome used for embarking, disembarking passengers, loading, unloading, cargo and mail, as well as the servicing of aircraft is called what? So if you look at this picture over here, you have aircraft parked over here at this place. You have this bridge to embark and disembark passengers, through which the passengers will walk from the terminal building to the aircraft. Okay, via this bridge or through this bridge. Then over here you can see the loading and unloading of cargo is happening. Okay, also you can see many vehicles and many engineering materials down next to aircraft. So this is the place where everything happens, like loading, unloading of cargo, embarking, disembarking of passengers, as well as servicing of aircraft, like either fueling, any repairs, minor, major repairs. So you will also see engineering personnel around the aircraft. Okay, so at such a place where all these things or activities take place is called an apron. Is called apron. Okay, so question number 4 correct option is Bravo. Now at some airports you will find that you are transported from the terminal building to main aircraft, okay, to your main aircraft via a bus. So you all passengers get inside the bus. That bus moves a further distance, some distance, and takes you to some aircraft. So in such a case, when that aircraft is located away from the terminal building at some parking area, okay, that parking area will be called ramp. Okay, such places are called ramp. But some big aircraft which are close to the terminal building, like in the case of this aircraft. Okay, in case of this aircraft, so there are bridges that are directly connected to the fuselage of aircraft. So these bridges will be connected to the doors. Okay, and through this bridge, the passengers will directly walk from the terminal building inside this aeroplane. Okay, to this aeroplane directly. Okay, but when aeroplanes are located far from the terminal building, They are transported to that particular aircraft via bus, car, taxi, whatever. Okay, and at such places where aircraft are parked away from the terminal will be called ramp. So apron is where all these things happen, like embarking, disembarking passengers, loading, unloading of cargo, as well as servicing of aircraft. And if some aircraft is parked very far away from the terminal building at one particular isolated parking spot, that will be called ramp. Question number 5. Which one of the following heat transfers is an example of a convection? Now we know there are three modes of transfer of heat: conduction, convection, and radiation. Okay, radiation, that is example of radiation is the sunshine. Okay, the transfer of heat from the sun to earth. After that we have conduction. When one end of the object is heated, the other end will also get heated after some time. That is through the process of conduction. The third is convection. Convection is which we will study now. Now let's look at a very minor example of convection. So I hope you all know this. But now the first example that I want to take is the example that we can observe or we come across in daily life. So when we heat a pot of water, or when we boil that pot of water, the water which is close to the surface of the heat will first get heated up. Okay, that air layer or that water layer will first get heated up. Now when an object gets heated up, its volume increases, its density decreases. Okay, and as a result it becomes lighter and lighter as it gets heated up. So this water layer, okay, which is less dense, will rise above, and to replace that water layer, the cold high dense air will come down and replace that layer of water, and it will now start getting heated up by the ignition. Okay, so as a result this cycle is created in which hot layer of water, because of its less density, rises up, and to replace that or to take place of that, a cold dense water from the top layer of the pot, okay, or from the top of the pot will come down. Okay, so this way, as long as this heating process is continued, okay, this heat distribution will take place between the bottom layers of the pot and the top layers of the pot, okay, or the bottom layer water and the top layer of water. But this heat will be distributed in a way that the layer which gets heated, its density decreases, it goes up. To replace that, a cold dense air will come down. So on and so forth, a cycle is established, and this is called convective cycle, or the process of transfer of heat or distribution of heat through this process is called convection. Now let's take this example and on a large scale. Now the same thing happens in the atmosphere. Now what happens in the atmosphere? So in the previous quiz also I have explained this, the formation of a thermal low pressure. So the same thing I will explain again. So we have the sun in the atmosphere. Now the sun sends heat to the earth, sunlight, and that process will be called insolation. Insolation. Now during daytime, when we receive heat from the sun or solar radiation, the land surface gets heated up. The land surface gets heated up. As a result of this, the layer of air or the layer of atmosphere which is close to the ground or which is close to the land or in contact with the land will also get heated up because of the process of conduction. Because of the process of conduction. Now this conduction in the atmosphere, okay, is very small in scale. A very small layer of air in close to the ground gets heated up by conduction, but conduction is not the main process by which atmosphere is heated by terrestrial radiation. Okay, conduction is a very small, plays a very small part in heating up the atmosphere. Okay, then follows the convection, but the main process by which atmosphere is heated is due to release of latent heat. Okay, anyways, so due to conduction, the air layer which is close to the land surface will get heated up. As a result of this, again the same logic applies. This layer of air will experience a volume increase. This layer of air will experience a volume increase, density decrease, density decrease, and this air layer becomes lighter. So any lighter thing or object will come to the surface or will rise, and to replace that a heavier object or a heavier thing will come down to replace it, right? So a heavier thing or a heavier object sinks, but a lighter object floats. So by the same logic, this layer of air due to conduction heating will become lighter and lighter as long as this heating intensifies. Its density has decreased, its volume has increased. Next thing, so as a result of this lighter mass right now, this layer of air will rise up in the atmosphere, and when it goes up in the atmosphere, depending on the stability or instability of atmosphere, if the atmosphere is unstable, it will continue to rise, okay, till it encounters stability. If the atmosphere is stable, it will have a limited upward movement depending on how stable atmosphere is. So this vertical current of air is established. We call it updraft or a vertical air current. When the movement of air is vertical, it is called air current. When the movement of air is horizontal, it is called it is called wind. Okay. So this updraft is established. Now in place of it, now when this land is heated up and the air layer goes up in the atmosphere, in place of it is established a pressure, and that particular pressure is called a low pressure. It is called a low pressure. Okay, a low pressure is created, and in place of that, and this low pressure will result in updraft of air or vertical air currents. Okay, now second point, in this low pressure, okay, there will be an inflow of air. There will be an inflow. There will be an inflow of air from surrounding high areas, and this air will again rise up in the atmosphere after coming at low pressure. Okay, there will be first inflow of air, and that process is called convergence, because the airflow from different directions will converge at the low pressure region, because the movement is always from high to low, whether you take water, whether you take air. Okay, so this is a low pressure area created by a sunlight, created by the sun due to insolation, or this low pressure can also be called a thermal low pressure because the way it has originated. So this thermal low pressure will definitely be surrounded by a comparatively higher pressure around it or somewhere above it. So there will always be a movement of air from high to low. Okay, and that is called convergence of air at low pressure, because all this airflow will converge at low pressure. This all these air branches of air will converge at low pressure. When they come at the low pressure, what will happen? Again, that air layer will get heated up due to land surface. It will become lighter and lighter, and then it will rise up in the atmosphere. So this is the basic process of low pressure procedure. So this is what happens in the pot of water. Convective cycle is established. Okay, due to all the game is about density. Same thing happens in the atmosphere. Here you can see sun, warm air rises up in the atmosphere. To replace that or to take its place, comparatively cool air from surrounding environment comes down and takes its place. Again, that same cool air will get heated from the land and then it will rise. This cycle will continue till the land is heated, till there is the sun during daytime. After night time, this will diminish in value or quality. During daytime, depending on afternoon, time of the day, depending on the season of the year, the latitude you are at, the topography of the region, the insolation may intensify or decrease in value. So that will create so depending on that insolation or depending on how stable or unstable atmosphere is, this low pressure is created. Very strong low pressure, you can have weak low pressure, or you can have just an extension of low pressure which is called a trough. So which one of the following heat transfer is an example of convection? So heating food in oven, that is wrong. That is radiation. Boiling water in a pot, yes, that is right. Feeling sunshine is again radiation. Heating a brass rod, that is conduction. So correct option will be bravo. Question number 6. The minimum temperature in ISA atmosphere is what? Okay, so again this we have covered in the previous quiz. So what is the thing about this is that according to ISA, if this is your height, vertical axis is represented by height, horizontal axis is represented by temperature. We have 15 degrees Celsius at mean sea level. So ISA says the temperature will decrease at a rate of 1.98 degrees Celsius every 1000 feet. But this lapse rate, lapse means what? To fall back. So this fall in temperature with increase in altitude is 1.98 Celsius every 1000 feet. Now this rate of fall will continue from mean sea level up to a particular height, and that particular height is 36,090 feet. 36,090 feet. And the temperature that is achieved at this feet is minus 56.5 degree Celsius. Okay, beyond this altitude or beyond this height, the temperature remains constant at minus 56.5, or you get an isothermal layer up to a height of approximately 65,000 feet, approximately 65,000 feet. Okay, so this is the basic rule of ISA. So the answer to this question is the minimum temperature in ISA that can exist is minus 56.5 degree Celsius. Okay, all these values are Celsius. SI unit is Celsius. So minus 56.5 Celsius. Let's go to question 7. A parallel of latitude is what? Rhumb line, great circle. So let's consider Rhumb line first. Now the definition of Rhumb line is a line or direction, a line or a flight path of constant direction, right? Now take any particular latitude, starting from the equator to North Pole or equator to South Pole. Let's take two latitudes for our illustration of this concept. Let's take equator. Let's take equator first. Now we have North Pole above, South Pole down below, East here and West here. Okay, North, South, East and West. Now if I take equator, okay, and at this particular equator latitude I try to go eastwards, towards the easterly direction. Okay, if my goal is to stay at equator only at 0 degree latitude, I cannot go above 0 degree latitude, 1 degree, 2 degree north, 1 degree, 2 degree south. That is not allowed. if you stay at one constant latitude, that is 0 degree latitude equator, so there are only two possible directions that you can go without leaving that latitude. Okay, that is either you can go anti-clockwise, okay, like this. You will go follow an easterly direction, towards an easterly direction, or you can go westerly. If you go clockwise, you can go in the westerly direction. Okay, if you divert from this latitude, okay, if you go north, little bit north or little bit south, your direction changes. If you go a little bit north, it will become northeast direction. If you go a little bit south, it will become a southeast direction. So you were initially following easterly direction, then it changes to northeast, southeast, whatever. Okay, so will this situation be equal to this definition? The definition says the line of constant direction. That means your direction should not or must not change, right? So when you follow a Rhumb line at a particular latitude, you can either go east, or you can either go east or west, right? Now let's take another latitude. Let's take latitude 40 degree north. Again, same logic. You can either go easterly direction anti-clockwise, or you can go westerly direction clockwise, right? Either of them. Is there any option to go north or south? Yes, there can be an option. You can choose to go north, south, change your flight direction, flight path. But then that flight path or direction will not be a Rhumb line or Rhumb line track. Okay. So Rhumb line tracks or Rhumb line directions are along a particular latitude, can only be east or west, and therefore we say that all parallels of latitude are Rhumb lines, because latitudes have only one direction. Okay, if you go easterly, if you go clockwise along a latitude, it will be a westerly direction. If you go anti-clockwise along a latitude, it will be a easterly direction. Okay, so the directions are always remain constant for a latitude. So therefore all latitudes are Rhumb line tracks. Next thing is about our great circle. Next thing is, I will erase this all, about our great circle. Now what does the great circle say? According to great circle, a circle that divides the earth into two equal halves, right, and has the same center as that of the earth. Also, it has to cover the maximum area on the earth. So a great circle is a circle that divides the earth into two equal halves and has the same center as that of the earth. So according to this definition, the great circle among the latitude can only be an equator, which is a 0 degree latitude. Because according to this definition, equator is the only latitude which divides the earth into two equal halves, north and south, has the same center as that of the earth, okay, and it covers the largest area on the earth. If you take any other latitude, if you take 50-degree latitude, okay, it will have less northern hemisphere than the southern hemisphere, okay, or any other latitude, there will be this difference. Okay, so the only latitude that is in conjunction with the definition of a great circle is the equator. Apart from the equator, a meridian and its corresponding anti-meridian. For every meridian, there is another anti-meridian, the total of which both of them is 180. Okay, so a meridian and an anti-meridian together will create or will form a great circle. So when you come back to this question, a parallel of latitude is a Rhumb line and only in a special case, that is in a special case of the equator, it can be a great circle. Otherwise other latitudes are not great circle. Okay, so option A says a rhumb line. Okay, but it can never be a great circle. It can be a great circle in the case of in the case of the equator. Okay, so option A is eliminated. It is not a small circle. Okay, it can be a small circle if you take any other latitude, 10-degree north latitude, 20-degree north latitude, 30-degree north latitude. So any latitude other than the equator will be a rhumb line, and in a special case a great circle. So option number C is also in that manner correct. So in exam maybe you will get an option of both B and C. Okay, a great circle for all practical purposes except in poles, that is wrong. Okay, so let's go to, so option B and C both are correct. Okay, so any circle which is not a great circle is a small circle. So except apart from equator, all other latitudes will be a small circle. Last question for the day. A sound wave having a frequency of 300 Hz is traveling in a particular medium. Its wavelength is unknown to you. It travels a distance of 150 times wavelength in time t, tango. You have to calculate time t. So we have to draw two columns over here to solve this sum, very simple sum. We know that speed equals to frequency into wavelength, right? Speed equals to frequency into wavelength. Speed of sound wave 3 into 10 raised to 8. Frequency given to you is 300 Hertz. You don't know the wavelength. So let's write x in place of it. So x will be equal to 3 into 10 raised to 8 divided by 3 into 10 raised to 2, which is equal to 10 raised to 6. So your wavelength is 10 raised to 6 meters. Okay. Next, we have been given that this wave travels a distance of 150 times wavelength. So distance is equal to speed into time. So what distance is 150 times that of wavelength, right? Speed is 3 into 10 raised to 8 into time t. This t time we have to find out. So we know wavelength right now 150 multiplied by 10 raised to 6 meter equals to 3 into 10 raised to 8 into time t. So t will be equal to 2 seconds. It will be equal to 2 seconds. Option number bravo. Okay. So simple question. 150 times wavelength. So first we have found wavelength with the available information of frequency. Sound or speed of sound was not given. You should know that. So we got wavelength of 10 raised to 6 over here. Substitute that there. T equals to, okay, a little bit of correction over here in cross multiplication. T will be equal to actually 150 into 10 raised to 6 divided by 3 into 10 raised to 8. Make that correction please, which is equal to 50 into 50 divided by 10 raised to 2. 50 divided by 10 raised to, which is equal to 0.5 seconds. 0.5 second. Okay, so correct option will be not 2 seconds but 0.5 second. So cross multiplication, even you in your exam pay attention to that. So t stays in on one side and 3 into 10 raised to 8 goes to denominator. So that will give you 0.5 seconds. So the value of t is 0.5 second. So with this we come to the end of this quiz. I hope you have understood this lecture, you have liked this video, and if you have liked this video, do hit the like button, subscribe to the channel, and let me know your comments, your questions, your doubts, and do share this video with everyone. Thank you for your time. All the best.